السلام عليكم ورحمة الله وبركاته. مرحبا بكم to this course Aerodynamics and Thermo Machines. Here we will start within the first chapter, Aerodynamics, Introduction and Key Concepts. Chapter will introduce students with key concepts and information related to the origin and application of aerodynamics. Then we'll dive to essential variables and principal forces investigated by scientists in this field. Firstly, what is the importance of aerodynamics? Let's take historical examples. Why learn about aerodynamics? For a quick answer, just look at the following 5 photographs showing a progression of airplanes over the past 70 years. For example, the Douglas DC, as in the figure 1. One of the most famous aircraft of all time is a low-speed subsonic transport designed during the 1930s. Without a knowledge of low-speed aerodynamics, this aircraft would never exist. And the progression in the development of aircrafts is continuous until the innovative new vehicle concept for high-speed subsonic flight is the blended wing body shown in figure 6. The airplanes in figures 1 to 6 are 6 good reasons to learn about aerodynamics. Now, the origin of aerodynamics. The word fluid is used to denote either a liquid or gas, although they are different. So the study of the dynamics of both liquids and gases is classified under the same general heading called fluid dynamics. Besides, certain differences exist between the flow of liquids and the flow of gases. Also, different species of gases, like hydrogen, nitrogen, have different properties. Therefore, fluid dynamics is subdivided into 3 areas as follows. We have hydrodynamics that concerns flow of liquids. We have gas dynamics that is about flow of gases. And we have a specific topic of gas dynamics that is aerodynamics that is specifically concerned with the flow of air. So aerodynamics is an applied science with many practical applications in engineering. No matter how elegant an aerodynamic theory may be, or how mathematically complex a numerical solution may be, or how sophisticated an aerodynamic experiment may be, all such efforts are usually aimed at one or more of the following practical objectives. Firstly, we have external aerodynamics, since they deal with external flows over a body. And this is the focus of this course. The prediction of forces and moments on and heat transfer to bodies moving through a fluid, usually the air. For example, we are concerned with the generation of lift, drag, and moments on airfoils, wings, and so on. However, the internal aerodynamics, because they deal with flows internally within ducts, which was out of scope of this course. Now, let's get some fundamental about aerodynamics variables. A prerequisite to understanding physical science and engineering is simply learning the vocabulary used to describe concepts and phenomena. Aerodynamics is no exception. Let us start by defining 4 of the most frequently used words in aerodynamics: pressure, density, temperature, and flow velocity. For example, the pressure is the normal force per unit area exerted on a surface. However, the shear stress is the tangential force per unit area exerted on a surface. For the density is defined as the mass per unit volume. The temperature, for example, for a gas, is proportional to the average kinetic energy of the molecules of the fluid. Now, regarding the flow velocity, the principal focus of aerodynamics is fluids in motion. Hence, flow velocity is an extremely important consideration. The concept of the velocity of a fluid is slightly more subtle than that of a solid body in motion. As illustrated in the figure, the velocity and streamlines. Now, let's go to aerodynamics forces and moments, which is the main topic investigated in aerodynamics. At first glance, the generation of the aerodynamic force on a giant Boeing 747 may seem complex, especially considering the complicated three-dimensional flow field over the wings, fuselage, engine, nacelles, tail, etc. Similarly, the aerodynamic resistance on automobile traveling at 55 mph per hour on the highway involves a complex interaction of the body, the air, and the ground. However, in these and all other cases, the aerodynamic forces and moments on the body are due to only two basic sources: the pressure distribution and shear stress distribution over the body surface. So no matter how complex the body shape may be, the aerodynamic forces and moments on the body are due entirely to the above two basic sources. Now, pressure and shear stress distribution on the body surface. The only mechanism nature has for communicating a force to a body moving through a fluid are pressure and shear stress distribution on the body surface. Both pressure and shear stress have dimensions of force per unit area. As illustrated in the figure 8, a pressure is normal stress, act normal to the surface. However, the shear stress is due to tagging action on the surface, or the tangential one, which is caused by friction between the body and the air. Now, let's talk about the resultant aerodynamic force and the moment on the body. So the net effect of the pressure and the shear stress distributions integrated over the complete body surface is the resultant aerodynamic force. However, the moment on the body is, as sketched in the figure, is the moment of the force or the resultant force. In turn, the resultant air can be split into components, two sets of which are shown in figure 10. Now we have two primary forces that are investigated in aerodynamics: lift and drag force. Firstly, we have V infinite, which is the relative wind. T is far ahead of the body, so the flow far away from the body is called the free stream, and hence the V infinite is also called the free stream velocity. As illustrated in figure 10, by definition, the lift force component of the air resultants is perpendicular to the V stream, free stream velocity. However, the drag is the component of the resultant force parallel to free stream velocity. And also we have the normal and axial force. Sometimes air is split into components perpendicular and parallel to the chord. The chord is defined the linear distance from the leading edge to the trailing edge of the body. So the normal to the chord is the normal force. However, the tangential one to the chord is the axial force. And the angle between the chord and free stream velocity is called attack angle or angle of attack. Now let's explain in the lift force through the Bernoulli principle, because the lift force is the main one that make the plane not shut down. Bernoulli principle is one of the core concepts used to explain the generation of lift in aerodynamics, especially for airfoils wing. Bernoulli principle stated that in steady incompressible and frictionless flow of fluid, the pressure decreases as the fluid's velocity increases. So the application to an airfoil wing, a typical airfoil section is shaped as in the figure 11. The top surface is curved, causing air to move faster over it. The bottom surface is flatter, so air moves slower beneath it. According to Bernoulli principle, faster airfoil over the top, lower pressure, slower airfoil below, higher pressure. So the pressure difference creates an upward force called the lift. So in aerodynamics, aerodynamics forces are mostly expressed in terms of aerodynamic coefficients. So we have the lift coefficients and drag coefficient. This convention expressed in the form shown above dated from about 1920, but the use of some types of aerodynamic coefficient go back much further. So further details of this coefficient is present in the next chapter. So as a summary, the sources of aerodynamics, lift, drag, and moments on a body are the pressure and shear stress distribution integrated over the body. A major goal of theoretical aerodynamics is to calculate the pressure and the shear stress for a given body shape and free stream conditions that yield in the aerodynamic force and moments. In the second chapter, we will explore the aerodynamics of wind turbines and how aerodynamic forces drive the wind power industry. We will also talk about the maximum power output and coefficient of wind turbines. Thank you for your attention and see you there.